Hi, my name is Sarah Crump. I'm a PhD student in Geological Sciences and at INSTAR at the University of Colorado Boulder. My research is focused on reconstructing past climate change and past glacier activity up in the Arctic. So we're here in this beautiful glacial valley, and we're sitting up on a glacier moraine. So this is a ridge of rock material that a glacier deposited about probably 20,000 years ago. So you can imagine back then this entire valley was filled with ice, and this is all that now remains. So we're really interested in pinpointing exactly when the glacier was out to this point, and we can do that by analyzing these rocks for a very rare isotope, beryllium-10. This isotope tells us how long these rocks have been exposed on the surface of the Earth, which in turn tells us when the glaciers deposited the rocks here. So our procedure in the field is pretty simple. We come out and find nice big boulders perched on top of a moraine crest like this. We use a hammer and chisel to knock off a small sample of that boulder, and we take it back to the lab. And once we're in the lab, we crush the rock down into sand-sized grains, and we separate out just pure quartz from that. We dissolve the quartz, and then we have a series of chemical procedures that allow us to extract pure beryllium from the quartz. So this is ion exchange chromatography, and the way this works is we add our sample to a column, and then we run various acids through the column, and the different ions that are in this sample will come out. They will elute at different times, and the very last fraction that we pull out is the beryllium, which is what we're interested in. So once we've isolated beryllium through that chemical process, this is what we end up with. This tiny bit of clear gel at the bottom of this test tube is all the beryllium that was contained in that bulk rock that we started with. But this is what we're after, and this is what will tell us how long that rock has been sitting on the surface of the Earth. With some pretty simple calculations, we can then back out how long a rock has been exposed on the surface of the Earth, which tells us when the glacier was out at this point. And that really helps us answer some bigger questions about how glaciers respond to climate change, how they've responded in the past, and in turn, how they might be reacting to future climate change. I'm really motivated by better understanding how modern climate change is causing environmental changes on the planet. So by reconstructing how glaciers have behaved in the past, it helps us better predict what's going to happen as the Earth warms up.